Ladies and gentlemen, we forgot a very important topic from chapter 3 that we're going to cover now. And it's called Enantiomeric Excess, and it's a measure of optical purity of enantiomers. Let me just illustrate with a couple examples. If you have 100% enantiomeric excess, that means you only have one of the two isomers. And I want to remind you, enantiomers are the non-superimposable mirror images of each other. So they got the same name, except all the stereocenters are backwards for each. That's a way you can look at their names and figure out their enantiomers. The name is the same, except every stereocenter in enantiomer A is the opposite in a B. We have a way of testing how pure those things are in labs. I would like to remind you how important it is to be able to determine how much of each enantiomer there is, strictly based on our big mistake from the 50s and 60s, when we didn't think it was important to test the levels of each enantiomer, and we found out the hard way through thalidomide. You might want to read about that. It's not mandatory, but it was a terrible time in medical history, where we thought we thought the molecule cured morning sickness. Ladies, you would love that, right? Morning sickness is a terrible thing that happens during pregnancy for a large amount of women, and they thought they had the cure with thalidomide. What they didn't know was the other isomer that wasn't the cure, the one that made the ladies feel better, was an inhibitor of blood vessel growth. And babies in their third trimester are growing at an exponential rate. Mommy goes from here to here in the third trimester, right? That's all baby growth. And you need, for growing limbs and legs, well, they're limbs, you need new blood vessels, or else they're not getting blood. And if they don't get blood, they can't grow. So we had thousands upon thousands of birth defects, babies with little arms and little legs. And they were mostly in Europe, these birth defects. A few in Canada. I was very lucky because this was the time I was born. I'm very lucky my mother was not given thalidomide, because they didn't have the person we had in the States who did not let thalidomide hit the market because she didn't have enough data on the child results, okay, childhood toxicity results, and she needed that before she was going to sign off. And you know how hard it was for a lady to stand up to all those rich men trying to push this drug on her? She was a true hero. Her name was Frances Kelsey. Somebody's got to make not a movie, we're talking a week-long mini-series about her. I'm going to pause the video. I got to give a couple exams back. So stop share. Continuing. We have to do something called standardization of our experimental data before we can do a comparison with any literature values of alpha. What is alpha? It's the measure of how much a chiral molecule rotates a special kind of light. And this light is not that special. It's polarized light. It's been run through a filter. And what the filter does, it gets rid of every plane of the light. Light travels in waves. I will give you a full-blown hand demo here. Here's one wave of light coming right at you. Here's another wave, and it's perpendicular. Here's one at about a 45-degree angle. All those waves, 360 degrees of them, are represented by normal light. A Polaroid filter, those expensive sunglasses, polarizing glasses, gets rid of all of those planes except for one. So I'm just saying this is the plane that gets through my filter. And if you're a pair of enantiomers, one of them is going to rotate light that amount in that direction. The enantiomer rotates light in the same amount, but opposite direction. That's all you need to know about the theory of, the physics behind optical rotation. okay? If you have twice as many molecules, they rotate it twice as much. There's twice as many doing the rotating. If you have a mixture, like a 50-50 mixture, that means you have as many molecules rotating that way as that way, and they cancel. It's almost like you're testing water, because water's not chiral at all. Chiral molecules don't rotate light. A 50-50 mixture of two enantiomers doesn't rotate light either, for a different reason. They're canceling the rights with the lefts, okay? So that's called if you have a 50-50 mixture, that's a 0% enantiomeric excess, okay? You have equal amounts. If you have 100% enantiomeric excess, that means you have only one of the enantiomers and none of the other. The excess means how much more of. That's what excess means naturally, right? How much more of. So, hey, if you had a reaction, you have the excess reactant, right? Well, how much was left at the end? That's the excess, right? We have, I can give other examples, but let's move on. Solubility, you've got the amount that makes it a saturated solution, and everything after that is excess. Okay, different excesses. So 100% excess means one enantiomer and not the other. 50% enantiomeric, no, 0% means 50-50. What does a 50% enantiomeric excess mean? What are the 2%? If 100% enantiomeric excess means 100% one isomer, 0 of the other, and 0% enantiomeric excess means a 50-50 mixture, like equal amounts. What's a 50% enantiomeric excess? What's the ratio in terms of percent? 75-25. What's the difference between those two? 50. That's what I just told you about the enantiomeric excess. So molecule A plus its enantiomer, the total has to be 100%, because that's the only two things in there. Okay? The excess is how much more of the major enantiomer there is than the minor. And it's even easier than I'm talking about here, because it's just follow this practice in this determination of alpha, and the next step is to compare it to a literature value. We'll get to that in our activity 2. So activity 1 right now, we're over here. You have to obey these conditions, and I will never tell you these conditions. You have to know them. So alpha is the rotation. It's in degrees. 20 is just the temperature. We don't ever use that as a variable for our exercise. Okay? We just need to make sure our temperature matches theirs when we do our full activity, next activity 2. Concentration, you're used to units like molarity, right? Well, don't use molarity here. One, it's extra work that you don't need to do. It has to be the same units as density, if you can remember that. That's grams of the stuff being tested over milliliters of solution, okay? So in our examples, we have the grams and we have the milliliters. It's a ratio, but make sure they're not milligrams. They have to be grams. That's not hard, right? You have to make it not hard, or else you're not trying. Show you care. If you're going into healthcare and you don't know milligrams, grams, back and forth in your head, you'll be causing health concerns for your patient. You will. 10 times overdose, 10 times underdose. And that's only by being 1 off on the decimal. Okay? Not allowed. L is the path length. How big is the container with the sample in it? How wide? It has to be decimeters. Now, we're not in Europe over here. They know decimeters like they use it every day. Here, nobody uses decimeters. Nobody. So you got a meter. There's a meter. What's a decimeter look like? Deci is 1/10, right? We're about right here, aren't we? 10 centimeters. Decimeters, 10 centimeters. Because you got 100 centimeters in that and 10 decimeters in the same thing. How many 10s go into 100? 10. There you go. Decimeter, centimeter. They're off by 10. Okay. Let's just do these. Every one of them, we're going to calculate alpha D20. And we need to know the alpha observed. I'm going to set up all three here. Too bad I have an A for all of them. Some of you still have an A on the third one. In fact, all of you, don't you? That's the danger of the copy paste, isn't it? So fix your third one. And we're going to do A. How many grams are in 500 milligrams? And you're not using a calculator. Do not type 500 into anything. You're not allowed to type anything. 2/4 is one way to do it. Not my first choice, but it would work for you. What's a little lower ratio? 1/2. Don't say 0.5. It's not wrong. Do you want to be doing math with a 0.5 and a pencil? He says yes. It's bold. He has no problem with it, but trust me, these are my three favorites right here. This covers 95% of every test. I've done 500 many times, 250 many times, and 750 many times. I mean, some drug doses are like that, right? Yeah, Tylenol, ibuprofen. I don't know what goes as high as 750. Those are typical doses, right? I know the ibuprofen's 220. You guys are good. Okay. 750, I don't know what drug has that dose, but there's going to be one. So we have in the numerator, you just copy this. Alpha observed, it's on top. You got to learn this equation. Alpha observed is the observed rotation. Now, guys, I need a fraction for 0.3333. 1/3. I like it. I don't use the thirds as much as I do the other one. And students have trouble with thirds. They really do. Do you want proof? American historical proof? This is a funny one. McDonald's, right? 1/4 pounder, right? I think first marketed, I don't know what decade, 60s? I think it was Burger King trying to, hey, we can do better than them. We're going to sell a 1/3 pounder. More than half of America thought they were getting less hamburger. Yes, it was a study. More than 1/3 of America, the country, thought that 1/3 of a pound was less than 1/4 pounder. They think 4. 1/3, they think 3. They don't know what ratios are. No. Okay, so you're not those people, right? We need scientists to be better than that. Okay, so what ratio is 0.333333 as a fraction? 1/3. So you copy 1/3 degrees. How many grams is 500 milligrams? I need a fraction. That's 1/2 G. I don't need the units once you figured out you got grams. What's the milliliters? Straight copy from the given information. I need grams over milliliters. I'm doing it right now in blue and black. What's the milliliters in part A? 24. Don't need the unit. And what's the path length in green? So don't say it that way. Somebody said 0.5, but once again, I always pick the fractions to help you. Trust me, I really try to pick the fractions to help you. Okay, so somebody said 1/2. Okay. There's not a lot of help right away. Slowly, because a lot of you, this is math review. That's 1/20, 1/48. times 1 over 2. Okay? Yeah. If you divide 1/2 by 24, you get a real small number, right? 1 over 48. What's 2 times 48? I know it's hard. Well, guys, what's 2 times 50? It's real close. It's 100. Well, you're going to lose 2 on each one of those 50s. That's 4 off, right? 96. So we're talking 1 over 3. And actually, my first example is my hardest. 1 over 96, right? 96 over 3, right? 96 over 1 times 3. I'm trying to go real, times 1 over 3, sorry. Trying to go real slow here. I took the denominator and I flipped it and put it in the numerator, right? Do you want to show this? I mean, it's not mandatory, but there's your denominator now, right? And somebody said, yeah, 96 divides by 3, 33. 32, yeah. You know what? If you put 33, I'm probably going to forgive you. I mean, guys, if you're within a 1 or 2 degrees and you made a little boo-boo and you're not allowed a calculator, I'm not upset. You're real close, so it's not like you don't know a 1/3 pounder versus a 1/4 pounder situation. You just made a little boo-boo that's not going to kill anybody. Okay? So the answer is 32 for the first one, and I think the first one's our hardest one. So what fraction is 250 out of 1,000? Remember, 1,000 milligrams is a gram. That's 1 over 4. Oh, that doesn't go there. That's a, yeah, 1 over 4 is a blue. And what's the milliliters down there for the next one? 10? And path length, what is it? How many decimeters in 20 centimeters? Remember, 10 centimeters is 1 decimeter. That's a big old 2. And just what kind of rotation we got this time? 2. That's a nice one. You like that better, don't you? Oh, 2 over 2 cancels right away, doesn't it? Yay, finally a break. 2 over 2 is the same as 1 over 1. How about 1 over 4 divided by 10? What's that? So I got a 1. I got all my answers positive here. I got a dead parts on the screen. Over 1 over 4t, right? Times 1. That's a 40. Yeah, you got 3 sig figs in it. You want to get picky. 3 sig. Whoa. It will not change to red. That's fine. Okay. 32 for the first one, and make sure you know we're on the second one now. And wow. And third one. Purple. Good. I can't read there. So on top, you need the observed rotation, which is 12. And it's in red. I can't get red. And grams is what? 750 milligrams is how many grams? 3 over 4. How many milliliters this time? 5. And somebody said 8. They were correct. 8 decimeters. 8 divided by 4. Guys, if you're having trouble seeing this as a fraction times a fraction in the denominator, go like this. That 8's on the top. It goes times 3 over 4. 8 over 4. Don't use green. Use gray or something. I don't know. That's going to be a 1 and a 2, right? I'm not losing anybody, am I? 3 over 4 times 8, both in the numerator down there. So that's the 8 goes divided by 4. And I think the 12 can be done too with the 3. You want to do the 12 with the 3? That's a 4 and a 1 now, right? That got a lot easier. Let's see what we got. 4 degrees. Wow. All morning, and I was going to clean the screen. Keep saying it. 1 over 5 times 2, right? 4 over 2 is going to simplify. So this is 2 over 1 over 5 is 2. Well, I'll write it down. 2 over 1 over 5 equals 10, right? 2 times 5 over 1. Sigh. And I apologize. Half the time rotation's positive, half negative, and all my examples were positive. I'm sorry. I should have thrown one in there that was negative. And that's pretty much it. This is the first part of the calculations for your test question. And our next activity will be the full test question. So you'll be doing this as the introduction, and then you'll be finishing it off. So I'll stop the video here, and we'll pick up again very shortly.